Hello students. So today we are going to talk about the application of the radius ratio. Now जो बच्चों तुम लोगों को पता नहीं है कि radius ratio क्या है, make sure that in the description section you should check a link where you will find the introduction to the radius ratio. Okay, so let's continue to the application of the radius ratio. Now see, sometimes which you will find that not everything is perfect, right? Not everyone is perfect, not every material is perfect. Every material has some defect, and that actually makes separate from the different materials with each other, right? So in this ionic solids, we will talk about the different defects, and with the help of the radius ratio, we will try to explain the defect. Okay, so first let's talk about one type of defect which you will find in a very highly ionic compounds, right? Now, when I'm saying ionic compound, that means there are few factors you need to consider. Now, number one, let's say if we say that the compound is highly ionic, correct? The compound is highly ionic. What does it mean? Since it's highly ionic, that means its lattice energy will be very high. Very good. So we can say that U0 is very high. U0 is very high. Correct? Now, if your U0 is very high, that means there will be the efficient packing. There will be efficient packing. Correct? Efficient packing means the atoms, the ions, they packed very efficiently. And when they can get packed very efficiently, then the ions, the size of the ions are comparable to each other. That means the size is comparable. The size is comparable. Okay. Now, if the size is comparable, that means what we can say, the radius of the cation to the radius of the anion will be very high. Okay. That means we can say that RR, that is basically the radius of the cation upon the radius of the anion, this will be very high. Correct? And if this is very high, then what will happen to our coordination number? The coordination number will be also very high. The coordination number also will be very high. Now, think about it this way, that in a lattice, if the coordination number is very high, then what will happen? The lattice ions, the ions present in the lattice, they will not try to stay together. So what they will do, instead of staying together, they will try to come away from the lattice. That means, let's say, if one M plus ion comes out of the lattice side, so similarly, in order to make electrically neutral, one A minus ion will be also come outside of the lattice side. That means what we will get here? We will get here one lattice vacancy, and here will be get our the one lattice vacancy. That means bahar kya aega? One M plus and one A minus. So what does it mean actually? Since here it is creating a vacancy, that means the density of the crystal decreases. Now, this type of defect is called Schottky defect. This type of defect is called Schottky defect, which is a very, very important piece of defect happens in the solid. So, mainly you have to remember here very few important points. That is, number one, this happens for very highly ionic systems like sodium chloride, like potassium chloride, silver chloride, right? And in this case, your U0, that is the lattice energy, becomes very high, and there will be efficient packing, the size will be comparable, and the radius ratio will be very high. And as a result, the coordination number is also very high, and which actually leads to the ions, outside of the crystal lattice. And also, you need to increase one point, the density of the lattice decreases. The density of the lattice decreases, right? So this is called the Schottky defect. Now let's say if I talk about the another defect, that is another also, like what happens in the case of where you have not too much ionic, or I would say an ionic compound that is having some covalent character, right? Okay, so in this case, what we can say, that we can write here greater covalent character. Okay, that means that it leads to inefficient packing. That means it leads to inefficient packing. Inefficient packing. Correct? Inefficient packing, which is basically nothing but your lattice energy very low. Very low lattice energy. Right? Because if you provide some amount of energy, the lattice will break. So if it is inefficient packing, then we can say the radius of the cation is very, very less than radius of the anion. Perfect. Now, if this is true, then what we can say, the radius ratio is very low. The radius ratio is very low. Now, if the radius ratio is very low, then the beta coordination number also will be very low. Now, each ion, if it has the lower coordination number, वो क्या करेगा? That will actually try to increase the coordination number, right? And obviously, na, when let's say you feel that you are alone, what you will do? You will try to fill those places with the new friends, new friendship, relationship, not like that. So similarly, ions also, what they try to do, they try to fill up those places. And as a result, what happens? Let's say there is a normal ion present in the normal lattice site that will actually leave its lattice site and it will go to some interstitial position. Similarly, the cation also will migrate. Cation also will migrate and will go to some interstitial position. That means finally at the result what happens? Between the few ions, the ions goes and aggregate together, and similarly the anions also, they go and aggregate each other. Right? Now, this kind of defect is little bit different, okay, and little bit innovative. And this kind of defect is called Frenkel defect. This kind of defect is called Frenkel defect. Frenkel defect. So, this is a very important piece of information. So, what is the important points here you need to remember? Number one, the Frenkel defect happens to those kind of system where you have a greater covalent character. Number two, where you have an inefficient amount of packing, and as a result what happens, the radius ratio becomes low, and as a result the coordination number becomes low. So what happens, the ions leave the normal sites and they go and fill up in the interstitial sites. And will there be any change in density? No, definitely not. So there will be no change in density. So there will be no change in density. Okay. So finally, so this is the one of the major application of the radius ratio. So basic, so 5, I hope your concepts are clear. So from my side, from the PrepMed team, if you have any kind of confusion or question or any doubt, feel free to write in the comment section and share this video with your friends and everyone. So thank you everyone. Take care. See you next time. Until the next.